Alright, in this video we're going to talk about a second technique, which is volumetric slicing and layering. And we won't spend too much time on this because there's not a good method in Blender for implementing this, but we'll use Blender to demonstrate it. And if you want to know more about it, you can view my original implementation in a different software here, and also there's a code example hosted on GitHub. So the concept is that we kind of start with a property of a model without undercuts and work backwards. So in a model that has no undercuts from a particular direction, as you travel down through the slices, every slice above a certain slice will be encompassed by the slice below it. So meaning the slices above will not overhang any slices below. So the way I implemented this was, and this is just a little simple example here. So I'll take a moment to show. Alright, so here I have a very coarse 10 slices. And what we do is we just take each slice, and if I, what's a good way to show this here? Okay, and we just add that slice to the slice below it. Which there's really not going to be a great way to show that. Maybe if I look from above, and meaning so here's the slice below, here's the slice above, this area would then be added to the slice below it. And you just do that all the way down the stack, and when it's all said and done, you have a model with all the undercuts removed. So it's a decent technique, except that you have to slice at really high res. The same thing here, where this slice, and I'll hide this one, where this slice overlaps this slice, this area would be added to the slice below it. Same thing all in here and all in here. And with a voxel, with like a 3D grid voxel data structure, that's very easy to do. If you have to work with contours like this, it's much more difficult. So Blender is not really particularly suited to this, but this kind of technique came to me, and I knew that Slicer had pretty good voxel data handling, so that's been kind of worked up here, but does need some improvement. Okay. Some of the benefits of this are that because you're working with a volume data structure, you then have to create an isosurface when you're done. So usually a marching cubes technique is what's done, and that always creates a nice watertight model. The cons are that we must slice it at a lot of really closely spaced slices to get good results. So that's about all we'll touch on for that case. It is kind of neat to see this model all sliced up. All right.